Okay, we're going to move on to Unit 9 stuff. All the questions on this page are found in 9.1 of your notes. As far as important things to remember here, you need to know that central angles, meaning angles that stem from the center of a circle, central angles have the same measure as their intercepted arc. Well, what does that mean? That means that because this angle is 75, this is the intercepted arc that goes with it. Basically, it's that angle goes through this piece of the arc, so it's intercepting. So this angle measure is also 75. We are going to be looking for measure of angle JKH. So this is what I'm wanting right in there. There are a few other things I want you to notice. Diameter is half the circle. It's also a straight line. So diameters are going to represent 180 degrees. So I see that all of this needs to be 180, or there's all of this needs to be 180, or all of this needs to be 180. There are a lot of different diameters going on here. And then we also have that two diameters create vertical angles. Which we know to be congruent. So you see this is 75, which means this angle here is also 75. Okay? I have a 75, I have a 52. I see I have a diameter along here. So if I want to find this guy here, I'm just going to go 180 minus 75 minus 52. And my calculator, aka my phone, just died, so it's going to take me a second to just type this into my computer here. 180 minus 75 minus 52, 53. So that's 53 degrees. Okay, so JKH is that. Once again, this piece here, it actually wants the angle, but I don't have another color to show you. So we're just going to do 75 plus 53, and we're going to get 128 degrees. Okay, so that's central angle stuff. We're going to move on to inscribed angles. Hold that up a little. All right, with this one, let's see, an inscribed angle is an angle with vertices on the edge of the circle. So see 1, 2, 3, that makes it inscribed. Okay. As far as how does the angle relate to the arc, well, 2 times the angle gets you the arc. You could also write that as the angle equals 1/2 the arc. Those mean the same thing. So if I'm trying to find this arc here, I see this piece is 110. I don't have this. This is where I think you guys have said like the snow cone thing. I'm going to grab a different color real quick so this chair doesn't stick to me. Okay. So basically, I like to highlight both sides that make that angle, And now I'm just going to connect around the circle between them, because that is the arc that goes with that angle. Now, as we saw, 2 times the angle gets us the arc. So going this way, I'm going to multiply by 2 to get 160. Well, to find that remaining piece, I have every other side, well, circles don't have sides, but every other arc of the circle. And full circle, as we know, is going to be 360. So I'm going to do 360 minus 110 minus 160. And that's going to get me 90 degrees. 51 is like the exact same thing. So maybe we should do something like 52. That's probably a good idea. Okay, honestly, you just got to start with information you know. I want you to also recall that diameters are 180 degrees. That's going to help you a lot in something like this. Here's what I know. I went here first because that's the angle I saw. So I'm going to connect it. And now remember, 2 times the angle gets you the arc. So 58 times 2, that should be 116. I'm going to double check that just in case. 58 times 2. Yep, 116. Okay. Well, I also see there's a diameter right there, which means this full thing has got to be 180. So if I want to find this piece here, I'm going to do 180 minus 116, which is 180 minus 116, 64. And I'm trying to find that angle. Well, here's the side that makes it. Oh, how convenient. And as we see from this property, we also know the angle is half the arc, meaning I'm going to take that 64 and I'm going to divide it by 2. 64 over 2, that is 32 degrees. Oh, you didn't even see that. 64 over 2, 32 degrees.